Hey, Dr. Alan Christianson here with you, and let's talk about all things umami. So you may have heard the term before, maybe not, but let's take a deep dive in. I think it's a really fascinating thing. So this is one of the last few discovered tastes, up until last year or so perhaps, or last few months, or maybe have a newer one. But this one was discovered in 1908 and by Professor Ikeda. This was thought to be almost a mix between savory and salty. So to date, we have 5 or arguably 6 tastes that we know of, and they're all a little bit different. So there's the sweet, sour, salty, bitter, astringent. You could also talk about pungent, umami, and starchy. That's 8. Sweet, sour, salty, pungent, bitter, astringent, umami, starch. Okay. So some of these are different in that they have classical taste bud receptors and some do not. So 2 of these don't have taste bud receptors, and I'll talk about that. So classically, actually having spots on the tongue or papillae that respond to them, that would be these 6. Now umami was the 5th one that we learned about. The pungent, which you could call hot or spicy, there's no taste receptor. That's just hot. That's just a chemical irritation. In fact, there's a compound called substance P that's on our tongues that's released. That's P for pain. And spicy foods put that into our bloodstream. And our brain recognizes, oh wow, something hurts. But we often interpret and frame that in a positive way. And over time, there's less substance P, so we can gain more of a tolerance to spicy. So then astringent, also not a true taste. It's more of a drying, puckering sense on the mouth. You know, imagine that you took an unripe banana and you took like 3 big bites and just chewed and chewed and chewed. Oh, it's not sour. It's astringent. It's drying to the mucous membranes. There's a little bit of that taste in legumes also, in some vegetables, but Ayurveda calls that a taste. Most contexts refer to tastes as just these other ones. So umami definitely does have its own receptor. And within this last year, we also recognize there's a distinct sensation of the starch taste. So we taste things that are starchy different than we taste sweet. And that was a newer understanding as well. Now all these tastes have different thresholds. There's the lowest threshold that we can detect, and the highest threshold, I should say the other way around, lowest one we can detect, and the highest one we can find pleasant. Now some are lower and narrower. So bitter, for example, has the lowest threshold of detection. If you've got a tiny, tiny amount of a bitter chemical in a glass of water, you would taste that. And things that have natural bitter taste, like certain greens or even coffee or chicory or things like that, the upper threshold of bitter that's pleasant is pretty low. There's a narrow range between, oh, I can taste that, and between, I don't like that. It's pretty narrow. Now here's the reason for that. Most bitter things are poisonous alkaloids in plants. So that's our protective system that, ooh, I'm going to spit that out. I can taste that and I don't like it. And interestingly, women, and especially pregnant women, have even more acute senses of bitter than other groups do. And we think there's a reason for that too. The amount of many types of plant alkaloids that are harmless to an adult could be dangerous to a developing fetus. So that's why pregnant women can often have just food cravings and food aversions, because their sense of taste and smell is ramped up real strongly. So bitter is low and narrow. The one that has the broadest range is the sweet taste, in terms of we can detect it at a lower threshold, and we can take a lot of it before it's becoming overwhelming. You know, salt and sour, they're lower, and they're in between that. Starch is a little higher than the salt. And umami also more moderate. So umami is pretty unique because we found that it has some distinct effects upon appetite. And this has been really misunderstood for quite some time. When it's mixed with proteins, it's been shown to have a biphasic response. So what that means is it affects your appetite in 2 different cycles. The first one is short-term and the second one is delayed. So in the context of the time that you're having a meal, things that are savory or umami, they stimulate your appetite. Like, oh wow, this is really good. But right when you're finishing your meal, that starts to kick in the opposite way, to where it ends up being more satisfying and it makes you want less food afterwards and less food sooner afterwards. You're going to stay full for longer. Your next meal is going to be more delayed, and your next meal is going to be smaller if you've got more savory foods. And it was pretty interesting. There was a big study done in which they showed this very clearly. They had a group of people that were non-smokers, not on meds, pretty normal amount of food cravings, no strong things like eating disorders, and also people that had just no real sense of food cravings at all. And they watched their responses to adding in various versions of umami extract to their food, their broths. And they saw exactly this biphasic response. Those that had it, not knowing it, wanted more food in the moment, or they actually should say they enjoyed their food more, but then after they were tracked, they took longer before wanting more food. And in follow-up meals, they consumed less food. So it was actually really helpful. Now, there's the question that always comes up about MSG, because these compounds, these umami compounds, are delivered through glutamate, and glutamate compounds that occur naturally in foods. MSG being a synthetic version of that. Honestly, here's a weird thing. The Adrenal Reset Diet book, when I was writing that, I was planning on making MSG and its various compounds to be one of the harmful things that can disrupt our body's cycles. And I thought it would be because there's been some other books written on that topic, like Excitotoxins, The Taste That Kills, and a few others. So I swear I had like a chapter written out, and I was going to plug in research after the fact. Well, now I've changed the cycle because of this experience. So I went to find the studies to support the popular beliefs about it, and I couldn't find any. I found really none at all. So there are theoretical concerns, and there are ways by which glutamate, when it's mixed directly with nerve cells in a test tube, no doubt that that's dangerous. MSG, there may be those that do have headaches or flushing from that. I consider the need to have a threshold of concern to avoid something pretty small. So I wouldn't say it is a smoking gun, it would kill you. But I see no strong reason not to avoid it when there are really good natural sources of umami readily available. So the other question that comes up is about glutamate, naturally occurring glutamates in foods. And I have read some accounts by which people have had concerns that glutamates in food could be neurotoxic, could be harmful and dangerous. Now that's a pretty clear case. The highest food source of glutamate is? Well, that would be human breast milk. So again, they've put purified glutamate on nerve cells in a test tube, and that's bad, but that's nothing to do with consuming naturally occurring glutamates in food. The way your body processes glutamate and the blood-brain barrier make it to where that effect you would get in the test tube is not going to happen as an interaction between food and your body. So glutamates in the foods that we'll talk about, definitely not neurotoxic onto themselves. Now, to be really refined, we'll talk about some things like seafood, for example, and you could have fish that has glutamate and has mercury, and the mercury could be neurotoxic. So just know that not all food that has glutamate is inherently perfect, but the glutamate itself is not a dangerous thing. So what are the food sources of umami that can make you filled up for longer and make you have better enjoyment of your meal? Well, by and large, we see this from meat, shellfish, riper vegetables, green tea. Some of the various highest levels we're going to find are going to come from fermented foods and yeast, so like nutritional yeast. You'll find this in products like Vegemite or Marmite. Also mushrooms like shiitakes have quite a bit of this. Some aged cheeses has it. Also soy sauce has it. My very favorite version of glutamate would come from the sea. Now you'll get it from seaweeds. The better versions of seaweeds that have that can also end up being rather high in iodine. So they're not my favorite, but fish products, really, really awesome sources of glutamate. And sardines, anchovies have that, but fish sauce is phenomenal as far as being a great version of glutamate. The better ones we'll talk about the nitrogen content. You can find those that are 40% nitrogen. They have less random inactive fish stuff and more of the purified proteins that give the flavor. They've got a long shelf life. They're fermented foods. They were used for many cultures as adaptogens or as tonics. And it's a really odd thing because if you open a bottle of fish sauce and take a whiff, it's pretty potent stuff. But if you drop a few squirts of it, small amounts into most any dish, it does really good things and it doesn't make things fishy. So have some, try it. You can make so many dishes tastier and be full for longer and need less food afterwards from using this umami. There are also umami pastes or umami bombs that I've seen. And those are almost like little tiny toothpaste tubes of a gel. Oftentimes tomato paste is part of that, which also has some umami flavor. And they may have some mixture of anchovies, parmesan, yeast, some things along those lines. And many of those will have parmesan, so those who are avoiding dairy products, that's an issue. But altogether, fish sauce, my favorite, and umami, good stuff. Good stuff, and making my mouth water just thinking and talking about it. Take great care of yourselves. Talk in really soon. Bye-bye.